Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video. Today we will go through different types of triangles and quadrilaterals and also their angles. So let's first look at triangles. So let's look at the different types of triangles. So these three triangles on your screen represent the three possibilities as to the number of equal sides and angles triangles can have. So it can have 0 equal sides, it can have one pair or 2 equal sides, or 3 equal sides. It's important to note that for any triangle, its number of equal sides is the same as its number of equal angles. So if a triangle has, say, 2 equal sides, it will also have 2 equal angles. If I tell you that a triangle has no equal angles, it will have no equal sides. So these are the three possibilities that we have. So a triangle with no equal sides and no equal angles is said to be scalene. You would have come across that term before. If it has 2 equal sides and therefore 2 equal angles, we call it isosceles. And if all angles are equal, then all sides are equal, it is called equilateral. So in addition to naming triangles by whether they have 0, 2, or 3 equal sides, we can also label them as to whether they are acute angled, right angled, or obtuse angled. So for any triangle, it can have at most one obtuse angle. So if it has one obtuse angle, we call it obtuse angled. So the other possibilities are that it doesn't have an obtuse angle but has a right angle. And again, a triangle can only have at most one right angle. In that case, predictably, we say it is right angled. But it is possible that a triangle has no obtuse angles and no right angles. That means all its angles are acute. So if it has 3 acute angles, we call it acute angled. So as we'll see later, equilateral triangles, for examples, always have to be acute angled. Their angles are always acute. An isosceles triangle, on the other hand, can be obtuse angled, right angled, or acute angled, similarly for a scalene triangle. So the obtuse, right, and acute angled aren't that important for what we're going to do, except to note that we can sometimes have right-angled triangles, and they will come up. They have their own special test when we come to congruent triangles. So just note, this is what a right-angled triangle looks like. It can be scalene or isosceles, but never equilateral, because equilateral triangles have to be acute angled. So a right-angled triangle, this side here opposite, facing the right angle, is always the longest side, and you'll see later we call that the hypotenuse. But the other two sides can be equal. They can also not be equal. So if they're both equal, these two shorter sides, then it would be an isosceles right-angled triangle. If they're not equal, then it's a scalene right-angled triangle. Just be aware of that. So we're now going to look at the angles inside a triangle. So what I'm about to do works for absolutely any triangle. So let's just draw a triangle, no matter how weird it looks. Let's say it's like this, okay? So I can pick any of the 3 sides to call the base. So I'll just choose this one. Wouldn't matter which one though. So this point at the top of the triangle opposite the base is called the apex. So what I can do is I can draw a line through the apex that is parallel to the base. I can do this for any triangle. So those 2 lines are parallel. So if I just label this angle here as the blue angle, notice that it is equal to this angle here. Why? Because they are alternate. And we looked at that in a previous lesson. Similarly, this angle here and this angle here are equal because they are alternate. And I'm going to call this third angle here, I'm just going to call it the yellow angle. So notice that the blue angle, the yellow angle, and the green angle, they are actually supplementary. Blue plus yellow plus green must add up to 180 degrees. But wait a minute, blue plus green plus yellow adds to 180. So you can see that because of alternate angles, the three angles inside the triangle, yellow, green, blue, add to 180 degrees. Now that works for absolutely any triangle, no matter how weird it looks. So the angle sum of any triangle is 180 degrees. Now this turns out to be very useful because we can use it to find unknown angles. Let's look at a few examples. So if we have a diagram like this, it's easy to find x because the angles inside a triangle must add up to 180. So 78 plus 58 is 136. So x will just be 180 minus 136, which is 44 degrees. How easy was that? So let's look at this right angled triangle here. Same thing, we have y plus the right angle plus 45 must add to 180. So y is just 180 minus 90 minus 45. Turns out y equals 45 degrees. So that means this angle and this angle are equal. So these two sides would be equal and the triangle would actually be isosceles. Let's look at a slightly harder example now. So let's now look at this example in blue. So you might be thinking to yourself, oh no, we don't have enough information. Well, actually we do. Because there are two equal sides marked, that's what these lines mean, the two sides are equal. This triangle is isosceles. So in addition to having two sides that are equal, it will have two equal angles. So those two angles in red will be equal. So those two angles must add up to 180 minus 36. So 180 minus 36 is 144. So x will just be half that. So it will be 72. So this angle here and this angle here will both be 72, and the third angle is 36 degrees. All right, I'm going to rub out these examples because we just need to quickly go through exterior angles of a triangle. So the rule for the exterior angle is on your screen. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. So just notice exterior means outside. So we're actually looking at an angle that's just outside the triangle this time. And interior, we're talking about inside. So what does this all mean? Well, let's just draw any triangle again. This will work for any triangle. So if we extend the base there, this one is what we mean as an exterior angle of a triangle. So notice that the red plus the blue must add to 180. But hang on, the blue plus these two angles, the two angles that are in green, they add to 180. This plus this is equal to 180. But the blue plus the red is 180. So this plus this equals this. So if I call this x, y, and z, then x is equal to y plus z. Okay, let's look at an example. Let's look at this example here. So the 120 degree angle is the exterior angle, and it's equal to the sum of the two interior angles that are opposite. So to find y is easy. 80 plus y must equal 120, which of course means subtract 80 from both sides. Y is equal to 40 degrees. Okay, so that's all for triangles. Let's now get on to quadrilaterals. So this chart here helps us classify quadrilaterals. I'm sorry that it's so complicated. It turns out that there are more than 3 types of quadrilaterals, where there's only 3 types of triangles. So that's why this is complicated. There are so many different types of quadrilaterals. So let's start at the top. We can firstly classify quadrilaterals according to whether they have 0, 1, or 2 pairs of parallel sides. If it has 1 pair of parallel sides, that's simple. It is a trapezium. If it has no pairs of parallel sides, if it has no equal sides as well, so no parallel, no sides equal, then it's an irregular quadrilateral. But if it has no pairs of parallel sides, it could have some sides equal. If it has adjacent sides equal, it is a kite. So please note the difference. A kite has adjacent sides, so sides next to each other are equal, whereas in, say, a parallelogram, it's opposite sides that are equal. So now let's look at shapes with two pairs of parallel sides. So there are lots of quadrilaterals that fall into this category. So any quadrilateral that has two pairs of parallel sides is a parallelogram. That also, having two pairs of parallel sides, means that it will have two pairs of equal sides, that opposite sides will be equal. But there are some special types of parallelograms we need to know. So parallelograms don't always have all sides equal. If a parallelogram does have all its sides equal, we give it the special name rhombus. A rhombus is also a type of kite because adjacent sides are equal, and it has the two equal angles characteristic of a kite. Those two angles are equal. Okay, so all rhombuses are parallelograms, but not all parallelograms are rhombuses. So parallelograms don't have to have all their angles equal, but if they do, then we call it a rectangle. So a rectangle is a special type of parallelogram in which all angles are equal, and that of course means that all its angles will be 90 degrees. So all rectangles are parallelograms, but not all parallelograms are rectangles. So people often get confused with this last shape here, a square. The reason they're confused is they think that if it is a four-sided shape with all sides equal, it must be a square. A square has to have all sides equal, but also all angles equal. A square is a shape that is both rhombus and a rectangle. It satisfies both definitions. And because of that, a square is also a type of parallelogram. But a square has to have all sides equal and all angles equal. Okay, I know this is complicated. There's also some more notes that you can read on the sheet, so please look through that and make sure you understand these definitions. We're now going to go through finding some angles in quadrilaterals. So any quadrilateral, no matter how weird it looks, has the same angle sum. So I'll just draw some weird quadrilateral here, okay? Looks kind of like a kite, but it's not quite. So any quadrilateral can be divided into two triangles. We have to divide it so that the angles of each triangle are at the vertices of the four-sided shape. So this plus this equals 180 degrees, but the same in the other triangle. This plus this equals 180 degrees. That's true of any triangle. So the angle sum of any quadrilateral, it doesn't matter which of the quadrilaterals it is, which of the many types it is, the angle sum of any quadrilateral is 360 degrees, 180 plus 180. So of course we can use that to find the unknown angles in a quadrilateral. Let's have a look. All right, so what would be the value of x in this quadrilateral? Well, that's easy. Of course, x plus the two 90-degree angles plus the 40-degree angle must equal 360 because the angle sum of any quadrilateral is 360. So 90 plus 140 is 220. So that, of course, means that x must equal 140 degrees. Okay, how easy is that? Let's look at a slightly harder example. So let's try and find the angle x here. So whereas the last shape was a trapezium because it had one pair of parallel sides, this shape here is a kite. It has no pairs of parallel sides, but adjacent sides are equal. So we need to know the properties of a kite. It turns out that these two angles, where the two different length sides meet, they are always equal in a kite. So we know that x plus the other angle that's equal to x, so this angle plus this angle, plus 28 plus 48, which is 76, must equal 360. So lucky we did so much work on equations, because you know how to solve this now. You just subtract 76 from both sides, and then of course you divide by 2. So x would be 142 degrees. How easy is that? All right, sorry for the long video. This has been the luckiest maths teacher in the world. Have a great day.